project, which is in BZ. So I looked at three ring networks of the BZ reaction. Okay.
The video's not playing.
Okay, yeah, you're really not going to be able to see this, but this is a video of the BZ reaction. It's actually red and blue. Just imagine that. So this is just, you see it on the next slide also. Okay. So the BZ reaction is a nonlinear chemical oscillator and it has two distinct phases. It has a reduced phase and it has an oxidized phase. So in our reaction, actually in this reaction, you need two things. You need a bromine source and you need an acid source. So the acid source that we use is malonic acid, and we use sodium bromate for our bromine source. So in this reaction, what will happen is the molecular bromine, so as the molecular bromine is created, it creates this red color. And every time it's consumed, it creates the bromine ions and creates the blue color, so kind of the light color that you can kind of see it there. So the reason why we study this reaction is because of its synchronization. So I think this one will show it a lot better. There we go. You can see it changing. But we do it because of its synchronization. As you can see in the other ones, how it kind of just did its own thing and there wasn't really any, it just had its own patterns. But when it's in a beaker like this, it's all together. And we look at it just like the heart. So the heart, when it's all together, beats as one. But if hypothetically you would take out every single cell in the heart, it would have its own beat. But when you put it back together, it beats together. So to create these droplets that we use to analyze in our programmable illumination microscope, which uses blue light to inhibit the droplets. We use a chemical called blue, which is blue light sensitive, so we can basically stop, with that blue light we can stop any droplets that we do not want to see oscillating. This is our microfluidic drop maker, which we use an oil surfactant to create a BZ emulsion. And we have two different syringes, one with the acid and one with our bromine source. We use two different substrates to look at this. We use capillaries and we use silicon chips. So the blue light's it's necessary, especially in capillaries, because if the droplets around the rings we're looking at aren't inhibited, it will skew our results and we won't be able to actually see rings. We'll see another droplet probably messing up and changing directions of our results. And silicon chips, it really didn't matter because they're in their own wells. And the wells are isolated from the droplets around it. The only problem is if the drop maker doesn't create uniform drops, we will end up with tiny drops that might also still inhibit our results, but it rarely happens. So we can still see the rings of three, but there might be a fourth drop that we don't see. So the purpose of these experiments that we were doing is to actually be able to control the direction of oscillation in our rings. So if a ring was going clockwise, we wanted to be able to change the direction from clockwise to counterclockwise by perturbing light on the head of the ring at a specific time right before its next oscillation phase, so it would just switch direction. The thing is, that was a lot of coding, and the code was there to do it, but for some reason it couldn't analyze and pick up when the next oscillation cycle was, so we were never able to complete the experiment. But we did see two results. The first result was the spontaneous switching. So the triangles are a little off, but you can kind of see the blinking on the screen. So there's a red and a blue triangle. Those both signify our two rings that had this spontaneous switching. So what happened was it switched directions on its own. So when two droplets oscillated together, it changed direction from, in both cases, clockwise and counterclockwise. The pink ring is actually the only ring in this cycle that stayed in the same direction throughout this entire oscillation cycle. The way we analyze this is we use space-time plots, which show. Yeah. Okay, so this shows oscillations, which are the white lines over time. Yeah, I don't see it again. So this is our control, and so what you can kind of see is how this continues to go up every single time. But every time it continues in the same motion. But in these blue and red, you can tell, especially on the red, there's two droplets that oscillate together and it changes it from an upward motion to a downward motion. Same thing happened here. It started off together, and then around, can't really tell anymore, but they oscillated together and it changed it from an upward motion to a downward motion again. Another thing that we use, this kind of shows it a little bit better, is we use radial time plots, which also show oscillations. So each line shows a different droplet in that ring over time. And hypothetically, what would happen in these rings is each droplet would oscillate 120 degrees out of phase with each other. So this is our control, and as you can see, it's kind of 120 degrees out of phase with each other. Same thing here, except the blue droplet and the green droplet switch places during the oscillation cycle. This one's a fun one. So this wasn't supposed to happen. I wish you could see this a little bit better. But what this is this is a sloshing. It's never been seen before, and we don't know what caused it. We're thinking it was a light problem because the microscope wasn't set up correctly, so it kind of inhibited two of the droplets, gave the droplets a little bit of light, causing the oscillation to slow. So what ended up happening, wish this was better, but there's a droplet here, here, and here. And what happened is it continued to, all three droplets oscillated, but they never connected between the droplet up here and the droplet down here. So it created this like zigzag C motion its entire oscillation cycle. So what we saw on our radial space-time plots and our space-time plots is the zigzag, because it never completed the cycle to create either a clockwise or counterclockwise motion. And the two outside droplets, so the red and the green droplet, were 180 degrees out of phase with each other, while the center droplet just did its own thing. So what they're doing now is they're trying to figure out how did this happen, because it was a good 2 days of material that continued to have this sloshing mechanism happen in it, and we don't know why that happened and what caused that to happen. So what they're doing now is they're looking into that, and they're also continuing to control the direction of oscillation in these rings. Okay. Yeah, that's just my thanks for Dr. Seth Creighton and my mentor Nate Tompkins, and also Dr. Olivia Mason, who invited me to come to Brandeis and be in this wonderful program.
So what are you going to be doing this summer?
I'm going to UPenn. I don't know what I'm doing yet.
Okay.
Awesome.
Now who are you working with at UPenn?
I don't know.
Okay. I just
Yeah.
wondered.
Paul, yeah. I don't know. Well, we can
Are
connect.
you doing chemistry project, or what are you doing?
I don't know.
Okay. do you have housing? Do you have? Are you on campus?
So,
Are you
so
okay?
the last thing I heard is I was supposed to know about my who I'm working with and what's supposed to happen, and that was like they said we'd know 2 weeks, like 3 weeks ago.
Okay.
So we're just still waiting, but they sent us an FAQ packet, so we know that housing is covered, travel is kind of covered, but they don't really pay for anything, and when we're getting our checks and what we have to do, a lot of it's just what we need to know to get paid and what to do when we get to campus, when we need to be there. But other than that, I don't know. Who's we? I'm going, and then there's another student here, Claude King, the third.
An engineer.
Yeah, who's also going with me.
All of the
You'll be at UPenn this summer as well?
I did not know that.
Awesome. You guys are only 15 minutes away from me, so we'll have to make something happen this summer. All right, awesome, Susan. I do have a question. So I know by this time you had only completed 1 year of undergrad when you did this research, correct?
Yeah.
Were there any concepts from your freshman year of engineering that you were able to apply during your summer research?
So I forgot to mention, so this was a physics lab. So the lab I was working in, well, Brandeis doesn't have an engineering program. So this was kind of chemical engineering, but it's on the soft materials side of it. So one of the things was the chemistry that I had learned in the first year kind of helped a little understanding what chemicals, kind of what was happening, but not understanding why it's happening, because this isn't a reaction that I know here we go over, but apparently at Brandeis this is one of the first things they show because it's so cool to watch. But that was one of the things, like the chemistry and a little bit of the mat lab, because their microscope runs on a good 6 pages of code. On top of that code, there's other code that's written into that code that you don't see. So understanding how that code works when it breaks down kind of helps a little bit too.
Yeah, awesome.
You get to interact with the other undergraduate students.
Yeah, so in our program, well, last year's program was all 6, sorry, I think there were 8 of us from Hampton who all went to Brandeis last summer. So there was a good Hampton group that I got to know while I was down there. On top of that, we lived in a housing unit that was with the bio RU program. So we got to know the people, a lot of them came from UMass. So we got to meet a lot of them, and also the undergraduates who worked in our labs, who were in a program sponsored by Brandeis. We got to meet a lot of them too.
Within midnight hours.
If you don't count our program,
It's interesting that it's 2017 and that's still the issues haven't
We've
changed.
been out here almost 50 years and it's nothing.
Like, one of the people that I met, he goes to Brandeis. He was actually here for the summer, and I met him when he came up. He goes to Brandeis now. I met him when he came up to Brandeis for the symposium at the inn. He enjoys it, and he says there are more people of color there. You just don't see them during the summer.
Okay, awesome. And do we have one last question for Susan before we move on? No? All right, let's thank her again.